Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 77 in our incredible new tutorial series where you're learning how to unleash the power of your Raspberry Pi Pico W. I will need you to pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you guys already have your gear, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 76. But I must start by asking, were you able to do the homework? If you were able to do the homework, leave a comment down below. I am legend. Double chest bump. And if you were not able to do the homework, leave a comment down below. I folded up like a cheap Walmart lawn chair. But never fear, I'm going to show you my solution to the homework assignment. And what was the homework assignment? The homework assignment was to control the position of a servo using this dandy little infrared remote control in your kit. And so that is what I will be showing you today. So let me get out of your way, have a little sip of the old Go juice here. And then let's switch over and let me start by showing you how I have this thing hooked up. Now I should start by saying, just pretend that this NeoPixel array is not connected, because that's actually the homework assignment that I will give you for next week. And so we're not going to be using it in today's lesson. But what we do have is we have a servo and we have the infrared receiver. On the infrared receiver, when the little LED is pointed towards you, the pin on the left is the control pin, and we have that hooked up to GPIO pin 17. And then the middle leg comes down to the ground rail, and the rightmost leg comes to the power rail. Let me get a little bit further out of your way. You should already have this hooked up, but if you don't, I will go into it a little bit more. It is physical pin 38 that I have coming down to create the ground, and then physical pin 36, and let me look at this and make sure that I'm saying this right. Yes, physical pin 36 is providing the power rail. Okay, so I've got control to GPIO pin 17. I have the center leg connected to ground, and I have the right leg connected to power. Okay, now as far as the servo goes, I have the control line, which is orange of the servo, connected to GPIO pin 16. Okay, and then I have the red wire power connected to GPIO pin 40, and then I have brown is ground, and that comes down to the ground rail. Okay, so it's really pretty straightforward to hook this thing up. Now, I must remind you that in using the servo, I'm sort of assuming that you're taking the class, but if you just jumped into this lesson, I created a servo library in lesson number 66, and if you've not created your servo library, you need to go back to lesson number 66 and get that all hooked up. Okay, so I'm assuming that you have that servo library in your Raspberry Pi Pico W, and then everything else should just sort of naturally follow from what I am going to show you in today's lesson. Okay, so that is the way that we hook our circuit up, and then I'm going to start coding I'm going to pick up where we left off in lesson number 77. And so let's get the code that we had developed in lesson number 76. And so what we can do is we can come over here to the most excellent www.toptechboy.com. Using the happy little search tool here, you need to search on something like using infrared IR remote control. Okay, and then you'll come to this page, and this is the page where we learned how to practically implement the remote, where we could get useful functions from it. Also, I'm assuming that you've already installed these libraries, which we did a couple of lessons ago, the IRX libraries, and I showed you how to do that a couple of lessons ago. So we're going to grab this code, and we are going to come over here and we are going to paste the code. Now we're just going to run it to make sure that it works correctly and that the universe is in proper working order and that I successfully got the code up on the website. Let's go ahead and run this. We have the handy little remote. Let me come over here to this view so you can see both things. And the way we have this remote set up is we begin our command. We say that we're going to enter our command with the power button up here. Then after pressing the power button, we can press a series of buttons like 1, 2, 3, and then to enter the command, we press EQ. And when we do this, look, we have this nice array that has our completed command. It starts with power, right? And then we entered 1, 2, 3. Those are our commands. And then we ended with the enter key, which I'm saying is the EQ key. So using this, I can press power, and then I can press whatever set of keystrokes I want, and then the EQ, and then I get that in a nice usable form. Okay, now down here in the while loop, what I'm doing in the existing program is I'm just seeing that, okay, yes, I have a new command. The command is ready to go. And then I print it, and then I say, okay, I've used that command, so I'm going to reset it to false. All right, and that sort of gets everything working. But now what we want to do is we want to use that new command to move the servo. So the way I would do that is I would say, press the begin key, and then let's say I said 135, and then enter. What you see I can get is I get the number 135. So what we would need to do in today's lesson is to take those numbers, whether it's a single digit 5 or 2 digits 90 or 3 digits 135, and then move the servo to that angle. Well, if we're going to do that, we're going to have to do a few things. And what I think I'll do is I'll come up here, and after I have my IR all set up, what I'm going to do is I'm going to set up my servo. So servo pin was what? That was pin 16, we said. And then I'm going to create my servo object. My servo is equal to servo uppercase, the library dot servo lowercase, the method. And then what do? I do servo pin that I just created. Now, if I'm going to use the servo library, I need to up here import servo uppercase, and then we can come over here and see that it is there if I say view files, all right, and then I come down to the Raspberry Pi Pico W. It's not showing me anything. Let me connect to it again. Okay, and now I look in the lib folder, and there is my servo library. Now, if you don't want to go back and watch that video, what you could do is you could just create the servo library right here. You could create the servo library, and then you would save it in the lib folder, and then you would be able to kind of follow along with this lesson. But I digress. Let's come back over here. Okay, and so now we have imported, I should spell this right, Doesn't count as an error if you find it before you run it. Okay, import servo, and then I create the servo object. Let's just run it to make sure we don't have any problems. Okay, it runs, so I haven't introduced any errors there. Now what I need to do is I need to come down, and I need to come down. Let's turn this view off. I'm going to turn the files view off. And then right here, what I did in my original one, I said, okay, if command is ready, that means that it has seen the power, it has seen a series of keystrokes, and then it has seen the enter key or the EQ key. So at this point, I have a command. Now, what am I going to do? Well, I'm going to start by just putting a little time.sleep just to give it, no, I don't think I need a time.sleep, okay. But what I do need is I need to create a string, okay. And let me run this just so we have something down here. Okay, so what I'm going to do is I'm going to say, let's say I do, let me come back to this view. Let's say I do power, and then I do 4, 5, and then I do EQ. You can see that I see this is a list or an array. The first element is always going to be power. The last element is always going to be enter or EQ, because that is what is necessary in order to generate this string. And then the stuff in the middle, is going to be the data that I need to create an angle to apply to the servo, if that makes sense. Now, I guess what I could do is there's several ways to do this, but you see, I don't know if it's going to have 1 digit, 5 degrees, or 2 digits, 45 degrees, or 3 digits, 135 degrees, something like that. So I've got to create a usable number from the data. And this is the way I did it. There's probably different ways to do it, but I think the easiest thing is to create a string. And so I'm going to call it my angle string. So let's make a string that would be like 5 or 4, 5 or 1, 3, 5. Let's start with that. But I got to start by making it just a blank. So I've created this empty string, okay? And then what I want to do is I'm going to go ahead and continue to print the command. I'm going to continue to print the command, okay? But then I'm going to say for I in new command, okay, what is the new command? This is going to be the new command when I get here. For I in new command, what will that do? It will step through power, 4, 5, and enter for this case. So I'm going to say if I is not equal to power, because power is going to be there, but I don't want to use it, and I is not equal to, what's the other one that I want to ignore? The enter, like that, okay. If it's not one of those two, then what do I want to do? Angle string is equal to angle string, like that. Angle string is equal to angle string plus string of I. Now, why do I make I a string? Because 4 is a number. I want to change it to a string. 5 is a number, so I want to change it to a string. And this plus is concatenation. So what would this do? It would start with an empty angle string, and then it would concatenate the 4, and it would concatenate the 5. Well, what if there was no 4 here? Well, it's going to ignore power, it's going to ignore enter, and angle string is going to be the string 5. So now I have a what? I have a string representing the angle that I want. Okay, and I think I'll print angle string just to make sure, help me debug in case I need to do a little debugging. Now, after it does that, and it goes through all of the commands in the new command, all of the elements in the new command, then what do I want to do? I want to say that angle, I want to change it back to an int. Angle is equal to int of angle string. So I turn that angle string, which in this case would be the string 4, 5, it turns that into an integer angle, if that makes sense. And then let's go ahead and let's print the angle. Now what you could try to do is you could try to do this like a 4 times 10 plus a 5 times 1, but that seems to get more confusing because the first digit, as you step through this thing, the first thing you see is a 4, and you haven't gone all the way through it, so you don't know if that's going to be a 4 followed by something else or a 4 by itself. If it was a 4 by itself, it would just be 4 times 1. If it's a 4 followed by another digit, it would be 4 times 10. If it was a 4 followed by 2 more digits, it would be 4 times 100. And that starts getting a lot more confusing. So I think it's easier just to do it. I think it's easier just to do it with do it concatenating the string. Okay, and I think that is the best way to do it. Now, what do? My servo was the object that I created, .pos, the method of the angle, like that, okay? Now, after I do all of this, I do need to set command ready to false because I got the new command, I have processed it, so now I need to set it to false. So then this upper part of the program up here, this callback knows that it's ready to start listening for a new command. Okay, it's ready to start listening for a new command because command ready would be passed up here. And then what's it looking for? It's looking for to see if it got another power. Okay, could it really be this easy? All right, now I just remind you that we do this IR close and we terminate cleanly. And you know what I think I will do is let's always reset it. So I'm going to say my servo.pos position is going to always go back to 0, so I start in that 0 position after the program terminates. So let's run this thing. Okay, now I'm going to put star, and I'm going to put, let's Control C. I'm just going to Control C, and why I wanted to always start with this at the 0 position. All right, now let's run it again, and what I'm going to do is I'm going to say power, okay, 4, 5, and equals. Boom! Oh, wow, I almost fell out of my chair on that one. Okay, look at that. And so it created the string 4, the string 4, 5, and then the angle 45, and then it applied it. So let's keep going. Let's say power, and let's say 90, and then the enter key. Boom, 90. Let's go power, and then let's go 1, 3, 5, and enter. Boom, 135 degrees. Let's go power. Let's go equal. What happened there? I hit power and enter without giving a command, and then it didn't find anything in here. And then in line 48, it was defining an angle that didn't exist. And so let's see if we can do a little, error correcting there. I would say here just angle is equal to 0 just to get started so that I don't have that problem. Okay, so now let's see if I do that. I hit power and equal, and it still crashes in line 49. Angle string. Oh, it doesn't know what angle string is, so I'm going to say, I'll set this angle string to 0 just to get started, okay, and angle to 0. Now it shouldn't crash, I think, if I did that. So I'm going to say power and then enter, and then nothing happened. Okay, power and enter. It doesn't fail. Now I'm going to go power, 4, 5, enter, 45. Let's try a single digit. Power, 5, enter. Boom, it goes back to 5 degrees. Power, 1, 8, 0, enter. And look at that, it goes to 180. I can go power, 9, 0, enter. And this little remote works pretty good. Like I'm putting it there so you can see it, but I can have it back here, power, 45, and enter, and boom, you see it's working really, really well. And now let's do the Control C, and the Control C program terminated. All right, now this was pretty easy, because what was the hard thing? The hard thing was what we did last week. The hard thing was what we did last week, which was to generate this code that allows you to have a user or programmer-friendly way to interact with this remote. And you can see the example that we have done with the Servo. The example that we have done with the Servo, it's going to be really easy to do anything that you want with this remote. Now, we would probably need to do some other error checking, so that if somebody came in here and they entered something that was not a number, like if we entered one of these keys up here that are strings, that we would check with that. We would check that and ignore keystrokes that were not integers. There's other error checking that you could do in here that would be really good. But how neat is that, right? I've just got this thing, and I can back over here. I can set it to something, and then I can do that. Let's see. I terminated the program. Let's run it again. So I can power 45 from way back over here, and boom. That is pretty darn slick, isn't it? Do you see how powerful this thing is? It's powerful because we created a very elegant way to interact with it. Now all we've got to do is we've got to come down here, have while true, that's our main loop, and we only do things if we have a new command. So we always are going to have if command ready is equal to true. And then after we execute the command, we have to remember to set it to false, so that it's not sitting there using a partial command or using an old command. So if you do that, then in between there, you can control kind of like anything that you can hook up to the Pico. How cool is that? I just think this is really, really neat. Kind of a short lesson, but hopefully, I'm hoping most of you guys were able to get it. It's time for us to talk about the homework for next week. Okay, now again, I am assuming that you've been taking this class, and I am assuming that you know how to use the NeoPixel. So what you can see is next week for the homework, you won't be using the Servo, but you will go back and you will hook the NeoPixel up, okay? You will go back and you will hook the NeoPixel up. And what your homework assignment is to now control the NeoPixel using the remote. Okay, you control the NeoPixel using the remote. So how am I going to do that? Well, I'm going to come in and press power. And then what do I want? I want NeoPixel. Let's say what I've done is I've now just labeled 1, 2, 3 and the various number keys to be certain specific functions that the NeoPixel would do. So I press power, and then I'm going to press I want NeoPixel program 3, and then I'm going to press equal. Hold on. Hold on. I was still on the Servo program. Okay, so now I'm going to press power, and I want NeoPixel program 3, and then I'm going to press equal, and I've got the running green, man. The green is running back and forth and back and forth. That's always kind of like been one of my favorites. But let's not forget our other favorite, which is power, program 2, and then equal. And then look at that. What do we have? We have the rainbow. We have the rainbow. All of the pixels are running the rainbow. Now I'm going to do power, and I'm going to do 1, and then I'm going to do equal. And now what do I have? I have the running rainbow, where each pixel is doing the rainbow, but it's doing it 45 degrees apart from each other. We did this in an earlier lesson, so you should know how to do that. Also, I can do power 0 and then equal. And then let's see if that's going to take. Yeah, there it is. Boom. That turned it off. Power 3. and we've got the running red man. And then if I come over here to the main program, if I come over to the main program and hit Control C to exit cleanly, it turns all the pixels off. Okay, so what your assignment is to go in and control your NeoPixel using the remote. And I'm going to be interested in seeing who can come up. I just did 3 just to kind of show you, but I want to see who can come up with the most bodacious set of NeoPixel programs that are controlled by the remote. Now, do you see in this homework assignment that I gave you, we are really getting to something that looks a whole lot more like something that would be a real product, right? I come in here, I turn on my running rainbow. I terminated the program. Okay, let me run the program again. And now I come in and I turn on my running rainbow, and boom, I've got my running rainbow. Also, one of the things that you have to think a little bit about, that running rainbow is a for loop inside of a for loop, and so it takes a long time for that to run through one for loop. But notice if I hit power and then 0, and then come in and press the equal, it very quickly terminates. It doesn't run through the whole, 45 seconds that it breaks in the middle. And that's a nice feature to put in on your program. Okay, guys, this was a pretty quick lesson though, but I'm just so jazzed about this thing, to be able to have all the different things that we can control with a Raspberry Pi Pico W, and to be able to control those objects through a remote. And then you could imagine even like connecting this thing up to your battery, and you could have a standalone little very neat little product based on this remote. Okay, guys, I hope that you are having as much fun taking these lessons as I am making them. When you do your NeoPixel homework, make sure that you post it to YouTube. When you post it to YouTube, leave a link in the comments below pointing us over to your homework solution so we can see your homework solutions. And then in your homework video in the description, link back to this video so people will know what you're talking about, or know that it's the solution for this specific thing. And then also people can easily find your video. So make sure that you do that. Guys, as always, I want to give a big shout out to you all who are standing with me on Patreon. It is your support and encouragement that keeps these great lessons coming. Also, you can help me by giving me a thumbs up and by leaving a comment down below. Both those things will help me with the old YouTube juice. And if you haven't already, make sure you subscribe to the channel. When you do, ring that bell so that you'll get notifications when future lessons drop. And as always, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.